Welcome back to the night class. Today we are doing lesson 7-6, and that's right, you guessed it, we are factoring more things. So today's they get a little harder. All of our problems the other day were very simple because this number out in front here was just 1. So when you have something like this, we've done one problem like this before. You always want to take the greatest common factor out first. So what would be my greatest common factor here? 3x. And then you'll factor. So we divide everything by the greatest common factor. And what will we have left? X squared
plus 5x minus 6.
And then you try to factor what you have left. So, what two numbers multiply to be -6 and add up to 5? And people miss this one all the time. So don't be that guy. 1 and -6? -1 and +6. I can't tell you how many times people will say 2 and 3, because does 2 plus 3 add up to 5? Yes. It does, but 2 times 3 is not -6. Okay, there's the problem. All right, remember, both things have to be true for them to work. All right, and then there's our answer. Okay, so I'm jumping ahead here because you actually won't do much cubes. Okay, but just so you know, the degree here was 3, right? That makes it a cubic. If the degree is 3, then you probably will have 3 factors. So 3x is a factor, x minus 1 is a factor, x plus 6 is a factor. Okay? If it's just to a quadratic, 2, how many factors do you think you'll have? 2. Okay? That's the way it works. All right. Our next example, more of the same. What can I take out of there? I can take out a 5. So let's see here. We'll have 5. And I can't take out an x, right? Because they all don't. 50 doesn't have one. So we divide everything by 5. So we'll have x squared minus 7x plus 10. So my final answer, what two numbers multiply to be 10 and add up to -7? What kind of 5 and 2? -5 and -2. Okay? Easy peasy. These are all we're doing here is basically combining the first two lessons, or that sentence, I shouldn't say the first two, the 2 lessons before this one. Okay? One lesson we factored out the greatest common factor. The next lesson we factored out a trinomial. Now we're putting those 2 things together. Okay? So what's my greatest common factor here? 6x. If I divide everything by my greatest common factor, that would be x squared. 30x squared divided by 6x is 5x. And 24x divided by 6x is 4. And so for our final answer, what 2 numbers multiply to be 4 and add up to 5? 4 and 1. Okay? Everybody good? Yes. Awesome. All right. Going to get a little harder.
Dang it.
I know, I'm sorry.
I had to say something.
All right, so here, notice, we're going back to our original, like, we had these problems, right, where we multiplied, okay? And so they're just showing you basically how everything is related, okay? When we multiply these out, notice they have everything written out, okay? And then they simplify things. Everybody see what I'm talking about? Okay? So it says the product is 6x squared plus 11x plus 4, okay? And it says notice that A times C. Now, which one of these is A and which one is C? A is the 6, and C is the fourth. Okay? Again, this is considered standard form of a quadratic equation. All right, ax squared plus bx plus c. So a is 6 and c is 4. It says, notice that a times c, or 6 times 4, which is 3 times 2 times 4 times 1, okay, is the product of all the coefficients and the constants from 3x plus 4 plus times 2x plus 1. So basically, they just took all those numbers and did what with them? Multiplied them together. Okay? That's the same as these two numbers multiplied together. You got me? And it always will be. All right? B, the middle step, says they are composed of pairs of the coefficients and constants from the original product. So you just have to figure out the pairs. So like 3 and 1, right? All right? And then 4 and 2 make 8. 3 plus 1 is, or 3 times 1, excuse me, is 3. 8 times 2 is 8. 4 times 2 is 8. So 8 plus 3 is 11. Okay? So all of this is just showing you the pattern. Okay? Here's what I want you to remember. Okay? This number and these two numbers. Okay? When we were doing them beforehand, we were figuring out just this number. What multiplied to be the last number, added to be the number in the middle. Correct? Okay? You're still doing that, but you have to include this front number here. On all the problems we just did, that front number was always what? 1. Okay? Even on one like this. See, it wasn't 1 to begin with, right? We took out 6x, and now it's 1. You follow me? So we figure out what multiplies to be 4, adds up to 5, and we can factor it. Okay? Well, we can't do that on this one, because if this was our problem, what would the greatest common factor be? 6x squared plus 11x plus 4. It's just 1. So technically, it really doesn't have 1. Okay? So when it doesn't have 1, you have to combine these. And that's the number you're going to try to multiply to equal. Everybody with me? Okay? Guess what that number is still? You're still trying to add up to be 11. Everybody with me so far? Okay? So there's two methods of how to do this. There's one called borrowing, and there's one called grouping. Okay? I'm going to show you both. You can do whichever way you like better. Okay? It does not matter to me. So, they start by grouping. Okay? Now, this is how they do it. I'm going to write it over here on my own because I want to show you what I'm thinking here. Okay? So, like we talked about, we're going to multiply the
Truth hurts. There's a whole song about it.
Okay, so these two numbers, 6 and 4, I multiply them together, and I get what?
Oh, you multiply and get 24.
I get 24. So as you notice, here's 24. All right, here's the factors of 24. They already wrote them down for me, so I'm not going to rewrite them. We need to ask ourselves, okay, 24. What multiplies to be 24? And they didn't write all of them, okay? They just wrote 2 and 12, obviously. What's 2 plus 12 there? 14. We need to add up to be what? 11. So then they try 3 and 8. What's 3 plus 8? 11. So these are our factors. So what I'm going to do is I'm going to rewrite my original problem up here, okay? And instead of writing 11x, I'm going to change that to 3x plus 8x. Okay? I'm getting these from my factors here. All right? So, 6x squared plus 3x plus 8x plus 4. Everybody with me so far? I've changed it, but I've only changed how it looks. Okay? I basically created 11x, and I made it 3x and 8x. Because what is 3x plus 8x equal? 11x. Everybody with me? Now I'm going to group them together. Okay? This is a group, and that's a group. Okay? What is the greatest common factor in this first group? 3x. And if I factored it out, what would I have left? Not 3x, but what? 2x. And then 3x divided by 3x is plus 1. Okay? The next one. What is my greatest common factor? 4. And if I took it out? Okay. Almost. So, here's what everybody has a hard time understanding because it's big and you think, oh, you can't do that. Yeah, you can. What do these two have in common? So I can bring that entire 2x plus 1 out front because that's their common what? That's their common factor. Okay? Think of it like this. I want to do it with something that you recognize. So like 6x plus 6y. Well, what do they have in common? 6. So I can bring the 6 out front and I have x plus y left. Correct? What do these have in common? 2x plus 1. So I bring that out front. And what do I have left? There are my factors. Remember when we first started? Okay. See how the factors were 3x plus 4 and 2x plus 1? Okay. Yes, sir.
How do you know? I'm just having a question. How do you know like what to split it into?
You get those from the numbers that add up to be the number that you need.
Okay.
Let's do another. Let's do 2 more. Yes, ma'am.
Like, where would you actually like find this in the real world? Like,
Anytime you need to factor something, you'll use it tomorrow and today in Algebra 2 and in Calculus and on the state test.
What about once we graduate college and stuff like that?
Lots of things. I don't know. All right.
You don't know?
lots of things that he doesn't know.
Yes.
Do you use this outside of the classroom?
You can.
Do you?
Do I?
Yes.
I
Yes,
mean,
whenever he's kidding.
no, probably not. If I were an engineer, maybe.
What were we talking about?
She's asked it the ever present question, when are we ever going to use this question? Okay? So it's like a lot of things in math. You got to know how to do this so you can know how to do some other stuff that you are going to use before. Okay?
English teacher. I won't ever have to use math.
You good? Okay. All right. So I'm going to rewrite this. I take the 10 and the 3 and do what with them? Multiply. Remember, you say the A times the C. Okay? So 10 times 3 is 30. What are the factors of 30 that add up to be 17? 2 and what? 2 and 15. So I'm going, here's the answer to your question, Preston. I'm going to change that 17x to 15x plus 2x. Because those are the two numbers that multiply to be 30, but add up to be 17. So I'm multiplying to be 30, okay, with those two, add up to be 17. Okay. And then I write the rest of it the same. And then I group.
You do the little thing.
It's called grouping, okay? So this first group, what do they have in common? 5x. And if I took 5x out of both of those, I would have 2x plus 3. What does that have for its greatest common factor? 1. Now, normally I wouldn't take it out, but when you're grouping, you need to take it out. So that's plus 1 times 2x plus 3. Notice, what do they have in common? 2x plus 3 times what would be left? 5x plus 1.
That's easy.
Okay? It's not bad. Everybody got part A? Okay?
So wait,
You good?
Like, I was wondering where the 17 was, and I was like, oh.
Here's the 17 right here. 15x plus 2x is 17x. And then you do your grouping from there. Okay? All right, one more like this, and then I'll show you the other way. So here, 2 times negative 21 is negative 42. We need two factors that multiply to be negative 42 and add up to 1. That does not add up to be 1. Okay, but that doesn't multiply to be 42. Remember, we just talked about it. If this is a really small number, that means my numbers must be pretty close. Now, they're opposites, of course, but they got to be close to each other. So what are the factors of 42 that are close to each other? 6 and 7. Okay? So I need which one to be negative? The 6. And again, it doesn't matter what order you write them. Okay? So I'm going to say 2x squared. And instead of saying plus x, I'm going to say plus 7x minus 6x. I'm sorry? Because they have to add up to 1. And if they're flip-flopped, they would add up to be negative 1. Okay? And then minus 21. And then you do your grouping. So, these two have what in common? X. And what would be left?
2x plus 7.
Beautiful. What do these have in common? One thing.
3.
Negative 3. And they will have 2x
Plus 7.
Okay? Now, if you haven't noticed yet, every time you do this, these should be what? The same. If they're not, you're probably messed up. Okay? All right? Now, I'm not trying to tell you they're always going to be the same, but for now, that they're just now teaching you how to do it, they'll probably be the same. Okay? And if they're not, that doesn't mean you're wrong necessarily. It just means I would double check my work. Okay? So, since these are the same, I can bring these out front. 2x plus 7 times x minus 3. Okay? Everybody good? Awesome. We're about to do everything again, just a little different way. Again, it doesn't matter to me which way you do it. What's this called again? Grouping. Because some people might like the other way better. I like having options. Okay? I understand. Some people don't. All right. So, this is called, they call it substitution. I call it borrowing. Okay? So, I call it borrowing. And this way, I make it look like the easy ones. Remember we talked about earlier before what an easy one looks like? So, I just make it look like the easy one. And the way I do it is by borrowing this number in the front. And I haven't said this yet, and I should have. Always, always, always try to take out a what first? Greatest common factor. We haven't done this yet on any of these because they haven't had a greatest common factor. Okay? But if they have a greatest common factor, you take it out first. And then if you still need to borrow or group, you do it. Okay? So, this one, like the rest, they do not have a greatest common factor. So I'm going to borrow this 3, okay? This 3 right here, and move it to the end. Now, what do you think I'm going to do when I move it? Multiply, just like I did on the other way, okay? So that will be x squared minus 2x minus 24. That looks better, huh? We just did like 16 problems like that, okay? Now you work it out just like you have been. What two numbers multiply to be negative 24 and add up to negative 2? Which one's negative, which one's positive?
-6.
-6, +4. Okay? Now, here's the downfall of this method. A lot of people get here and they think they're finished. Okay? You're not finished because remember, when you borrow something, you what? You give it back. Okay? So how did we borrow it? What did we do to borrow it? We multiplied, so how do you think we're going to give it back? Divide. I'm going to take both of these factors and divide by whatever I borrowed. 3 in this case. Okay? So, this reduces to x minus, what is 6 divided by 3?
3.
X minus 2. Why is this pen doing that? Okay? This one, 4 over 3 is just 4 over 3. So, all I do here, first you always reduce your fraction. Is 4 over 3 reduced?
Yes, sir.
So all I have to do is take that denominator and put it in the front of your x there.
3x.
3x plus 4. Okay? Same thing we did. I'm going to do it the grouping way just to show you the difference. Okay? So had we grouped it, it would have been 3x squared. We decided that it was going to be -6x plus 4x minus 8. Group these two, that's going to be 3x, and we get x minus 2. Group these, we're going to bring out a 4 and get x minus 2. They both have an x minus 2, so we can bring that out, and we're left with 3x plus 4. Same thing. Does not matter which way you do it. Everybody got me? It's just a matter of, even the work is about equal, to be honest. Okay? This way, the borrowing, you do have to remember, one, I got to put it back. Okay? And two, if you do need to reduce, you have to reduce first before you move that denominator to the front. Okay? Everybody with me? All right, we'll do a couple more the borrowing way. Like I said, that's just what I call it. You might have another teacher later on that calls it the tick-tock, no-toe. There's a whole bunch of different. Yes. Forget I said that. Don't worry about it. All right. So we're going to, don't worry about it. Don't worry about it, sweetheart. All right. So we're going to borrow. That'll be x squared minus x minus 12. Now it's an easy one, right? What two numbers multiply to be -12 and add up to -1?
I don't know.
12. There ain't many numbers.
4 and 3.
Which one's negative?
-3.
-4.
-4, +3. What did we borrow?
2.
So make sure you divide by 2. That'll be x minus 2. Does that reduce? You just move your denominator to the front. Okay? Everybody good on that way?
Do we have to do it that way?
No. No.
That's why just thought I'd ask. I told you.
I literally said at the very beginning, it doesn't matter to me which way you do it. All right, I'm going to do one more. So, borrow the 10. That'll make that x squared plus 3x minus 10. What two numbers multiply to be -10 and add up to be 3? Come on, 10 ain't got a lot. Let's go.
5 and 2.
5 and 2, which one's positive?
Positive
+5, -2. What did we borrow?
The 10.
We borrowed the 10, so divide by 10. Okay, this is a good one. We have to reduce first. Y'all listen, we got to reduce first. So this is x plus 1/2. And then we got x minus 1/5. Does everybody see that? And now you move your denominator. So that'll be 2x plus 1, 5x minus 1. Okay? Everybody good?
Yes.
Not too bad?
Oh, where's your...
All right. There's just our little concept summary. You have a few to try on your own. We're going to call it a day. And everyone out there, have a great day and stay above the line. See you next time.
Chicken.